already know, I think. David is young, but he's a very prolific scholar in the field of tourism economics, in a variety of topics, I must say, mostly in topics related to microeconomics or on the impact of tourism on regional development, but he has a variety of interest out of tourism, too much to discuss them all. He has a lot of paper already published, something like 70, I think, in prominent journals. And of course, he's already an established scholar. He's currently a tenure assistant professor at the University of Oviedo. And for me, as usual, it is a pleasure to hear one of his presentation. Today, we will have a paper written with Maria Santana Gallego entitled Roaming from Home, Roam from Home, sorry. And David, if it's okay for you, I leave you the floor.
Well, thank you all for being here, for attending this seminar. Thank you, the organizers, for inviting me, and also thank you, Sawah, for this fantastic introduction. Thank you very much. This is, as you said, a work in progress with Maria. I did a visiting stay last year, and I plan to go back this year. And this seminar is now a perfect timing because we are still working on it. So we will appreciate all the comments and suggestions to improve the paper. So feel free to tell me whatever you think about it. Well, this is the outline of the presentation. I'm not going to waste time on this. I start with the motivation of this paper. Well, we can agree that digital connectivity is nowadays are a core and important part of international travel. The availability of data services allow tourists to search for information, to book their accommodation, to buy tickets, and there's a lot of research showing that the development of internet services and broadband availability has stimulated or at least facilitated outbound traveling. Because, you know, when you travel to a place where they speak a different language, maybe even if you know English, we can take advantage of translation services, Google Maps services, all this that make maybe the trip easier or facilitates doing some activities at destination. And also the use of these applications that, for instance, there are some cities that have apps where you can see the most iconic sightseeing spots and all this. So in this context, we ask the following question. We ask, how does the elimination of roaming charges for mobile services affect tourism flows? You know, in general terms, when you travel to another country, you have to either purchase a SIM card or pay special roaming services to enjoy your mobile phone data. We are going to see or study what happens when these costs are reduced. And to do so, we exploit a policy that was implemented in the countries that belong to the European Economic Area in 2017. Okay, in January, these member states plus the three other countries, Iceland, Norway, and Liechtenstein, agree on abolishing the the roaming charges that people had to pay before for using mobile phone services. And this became effective in June 2017. Okay, so after this policy implementation, citizens could travel within this country and use their mobile phone without additional cost, okay, as if they were at home, and that's why the policy is Roam Like at Home. This is the name it has. And obviously this constitutes a reduction in the cost of using digital services while on a trip. It is true that maybe this represents a small share of total cost, but obviously it facilitates, it generates, it makes the trip easier, and it's not just the price, it's also maybe you don't have to worry about this, about going to your network company and apply for a special tariff for a special service. And to do so, we will work first with aggregate data using bilateral flows between countries. We will use a gravity model and difference in differences identification strategy. And we also provide some complementary evidence based on survey microdata to complement the main findings. As a preview of what we find, in general, according to our estimates, the tourism flows between the pairs that were affected by the policy increased by around 6%, more or less. We document some relevant heterogeneity based on distance, based on GDP, and based on linguistic similarity, which I discuss later. The survey data also show us that following the policy, people reduce using. They stop needing to have to purchase additional SIM cards, or having to switch off the mobile devices, or other types of behaviors that before restricted their capability to use the mobile phone. We show that after the policy, they started using mobile phone data similar to what they do at their home, in line with the policy's goal. So, well, the main takeaway that we get, at least for the moment, is that removing these roaming charges is welfare enhancing, or at least it is associated with an increase in tourism trips. And we try to show that this is new demand. It's not just a reallocation of demand, but we try to argue that this is new demand generated by this policy. As for the related literature, well, there are some, but not many studies on the topic. To my knowledge, there are only 4. These studies have been more focused on the industrial organization part of this policy and the competition between companies and all this. But I highlight this last paper by Quinn et al. In Economic Journal. They exploit data from network operators, and they show that more travelers use internet services than before. They show this translated into important consumer surplus gains. They also show that more intensive internet users benefited more, that there was a drop in the digital divide among travelers, so that the people from more disadvantaged backgrounds benefited more from this policy. And they also show that the increases in volume data, in the volume of data services, the larger increases took place during weekends and during holiday periods. And they show, or they argue, that in principle, this benefited more leisure travelers than business travelers. So this is more or less what we know, but to our knowledge, nobody has to date evaluated if this indeed affected tourism flows. And this is what we try to add to the debate. And in doing so, we try to provide evidence for this ample literature on international tourism, on the determinants on international tourism, and to see the role of digital connectivity and the role of these roaming charges. We have a very simple theoretical framework just to justify the channel through which we expect this policy to have an impact on flows. Okay, if we assume that destination choice is driven by economic fundamentals in the sense of Lancaster, okay, there's a demand for characteristics. So the indirect utility of traveler I for traveling to destination D is a deterministic component, which is a linear combination of some destination characteristics, climate, and others, okay, some destination factors minus the cost, the price of traveling there. And well, if we assume under random utility theory that it is not written there, but there's an idiosyncratic component, okay, so we have some probabilistic demand, then we can see, or we can characterize destination choice as the destination that maximizes the utility subject to budget and temporal constraints. But the important issue is that in this term, in this price, in this cost component, we argue that there could be three subcomponents. One of them is the transportation cost, okay, the cost of moving from origin to the destination. Then there's the on-destination cost, okay, the cost of accommodation, the cost of food, the cost of visiting sightseeing spots. And then there's this third component, this what we call the communication and information cost, which is the cost of being connected with your origin, okay, sending messages to your family, to your friends, sharing photos on your social networks, but also if you want to go in the destination to a museum, you search for where to catch the bus, the time at which the museum opens, and all these elements that are relevant for your travel experience. Okay, so well, this is at the individual level. Okay, we have a probabilistic demand, and then if we aggregate across individuals for each origin and destination, we can have an aggregate gravity equation where it depends on the classical determinants, the income of the origin, because the income determines travel participation. So wealthier countries typically have a greater proportion of the population that travels. We have these deterministic elements that determine demand, pull factors, okay, these vary at the destination level, and these cost components that obviously enter with negative sign. And we argue, okay, everything else being equal, and this is the key issue for the identification, we would expect that if this cost of communication decreases, travel demand should increase in principle. Okay, this is more or less the theoretical argument. Then the data we use, we collect a panel data set of bilateral flows for all available countries in the world. In particular, we have 228 origin countries and 150 destinations. For this, the sample period goes from 2014 to 2019. We stopped in 2019 to avoid the problems of COVID. And we start in 2014 for two reasons. On the one hand, Croatia entered the European Economic Area in 2014. So in this way, we keep the group of treated countries fixed. We avoid compositional changes. And also, we have 3 pre-treatment and 3 post-treatment years. But it's true that well, we are now thinking about extending the pre-period back. Maybe we are discussing whether to start earlier in maybe 2011. So we have longer pre-treatment period to inspect parallel trends. And the data about this bilateral flows comes from the World Travel Organization statistics. Here there's some problems with the data. This data source does not allow us for the distinction between zeros and missing values. And therefore, the data set is a little selected for pairs with positive counts, okay? And well, we are discussing whether this could be generating a selection problem, okay? I am acknowledging this issue. And the data refers to people with at least one overnight stay at the destination, so same-day visitors are excluded. This may not be very problematic if we are talking about tourism, but it's true that there's a lot of cross-border traveling that maybe is relevant from an economic perspective, and we are not catching here. And the data refers to trips for any purpose, personal, leisure, or business. And for the moment, we are not able to distinguish the purpose. Maybe it would be relevant to have this disaggregation to see differential effects, but for the moment, the dependent variable, these bilateral flows are the total, okay? We cannot distinguish by typology. We have other variables in the analysis. We have a dummy for whether the country pair has a free trade agreement, and this comes from this database from large, which is updated over time. We also have a dummy for whether the country pair shares a common currency, for instance, in Europe, those that have the euro. Both the origin and destination real GDP per capita. We have distance between country pairs, and we have two indicators of linguistic similarity. One is just a dummy if they have a common official language, for instance, Belgium and France. And we have another index, linguistic proximity index, which we take from a recent paper by Gurevich. And this index is computed as the product of the percentage of native speakers of each language in each country. So it's something like the probability that two randomly chosen individuals from both countries meet and can speak the same language, more or less. Okay, so this captures more or less the similarity between countries. Our identification strategy, as I anticipated before, is a structural gravity difference in differences equation. We have the number of tourists traveling from origin O to destination D in GRT. And we have origin destination fixed effects. Okay, this alpha OD, this captures geographical distance, cultural distance, shared language, all time invariant factors affecting flows between a given pair. I explain this why later. We have also this gamma and delta OT and DT, and these are origin time and destination time fixed effects. So, well, this captures what the literature typically calls the multilateral resistance to tourism. Someone could say, oh, why are you using these fixed effects and not maybe plugging their GDP, population, other dimensions? Well, because our goal is to identify the treatment effect of the policy, we need to account for all confounding factors. So we believe, and the specialized literature in the gravity literature also says this, that it is better to control for all destination time varying and origin time varying factors through these high dimensional fixed effects. Because even if I plug here GDP, population, whatever, that could be many other factors that I ignore varying at the origin or destination that are relevant. And here the key variable of interest is this interaction term. We have here EEA, which is a dummy for all country pairs that belong to the European Economic Area. interacted with a dummy that takes value 1 after 2017. Okay, this is the difference in differences estimate. And we also have here 2 bilateral covariates that vary over time. And here are the free trade agreement and the common currency variables that I mentioned before. These variables are not accounted for by these fixed effects because these vary at the pair level, and they also vary over time, so they are not captured here. And in principle, in this specification under parallel trends, no anticipation, and the SUTVA stable unit treatment value assumption, in principle, this beta should identify the average treatment effect on the treated. We carry the estimations using Poisson pseudo maximum likelihood because, well, it has been said to be better than OLS. It is robust to heteroscedasticity and other issues. And as I was mentioning, the standard tourism determinants, which you could find in any handbook, in principle are captured in both these destination year and origin year fixed effects. I'm not interested in them. I don't care about the elasticity of tourism to GDP. I simply don't care. What I care is to get a clean estimate of beta, so I capture all these origin and destination time varying heterogeneity through these fixed effects. Well, here we have some descriptive statistics of the variables. I mentioned before that I have GDP, I have distance, I have linguistic. Yes, these variables I have in my database and others, but I don't use them in the main specification. I use them for heterogeneity analysis, as I will show you in a couple of minutes. So let's jump to the results. These are our baseline results. In the first column, we consider all country pairs, okay? And therefore, in here, the control group or the comparison group are all country pairs in which there's no European Economic Area pair, okay? So in here, when considering all, for instance, a trip between Spain and the United States enters there as a control, in the control group, okay? Because the treated are only pairs belonging to the European Economic Area. And according to this regression, there's around 6%. Well, you know, we have to calculate the exponential of this coefficient -1 times 100 to get the semi-elasticity, but around 6% is the estimate. And well, we have these other controls that the common currency is not relevant and the free trade agreement is positive and significant. Then what we do is, okay, we restrict the sample to European Economic Area destinations and European Economic Area origins. So in here, the control group, for instance, are, we have French people that travel to Spain as treated and American people that travel to Spain as control. Okay? And here the other way around, Spanish people that travel to France and Spanish people that travel to the United States. In one case, they are treated, in the other case, they are not. And in these subsamples, the point estimate is a little larger and is also significant. We also run an event study version, okay, with leads and lags, because the previous estimate is an average effect in the post-treatment period. So by running this regression, we can see if the effects are constant over time, are increasing over time, and also we can inspect the important parallel trends assumption. Well, in principle, it seems the parallel trends assumption is satisfied, although here it is significant at 10% level. And we see the effects are in the whole sample, the effects are more or less the same. However, when looking at these subsamples, so depending on the destination and depending on the origin, in here the effects seem to be increasing, and here also there's no effect for the first year, and then in 2018 and 2019 the effects are also increasing. Well, however, you know, this issue of parallel trends is a little tricky, even though in this regression the lead terms are not statistically significant, and this could be a check or a test for this assumption. There are some people that say that maybe you cannot find differential trends when in reality there are. Okay, this is a little tricky, so you need to provide additional tests, additional checks to provide convincing evidence. One first falsification test that we do is we create a fake treatment taking place 1 year before. So the treatment starts in 2016 instead of 2017, and we use only pre-treatment data. Okay, so basically what we are checking if in treated countries there's a differential behavior in 2016 as compared to the previous 2014 and 2015 years, and there's no significant difference. So in principle, this falsification test could be used as a valid test for this important no anticipation assumption. But there are more issues to be discussed. Another issue is the stable unit treatment value assumption. The intuition here is, okay, to get a treatment effect, you need to rule out that controls are not affected by the treatment. So one could say, okay, if I was a French individual that I was planning to travel to, I don't know, to Morocco, so my plan is to travel outside Europe, but then I see that the roaming charges are abolished in Europe. Maybe I decide to travel to Norway, for instance. So if I substitute traveling outside for traveling inside, then the treatment group is contaminated, okay? Because there's a substitution effect. I don't know if you are following my point, okay? So to check that this assumption is valid, that that control units are not being affected by the policy, what we did is we exclude treated units from the sample, okay? We exclude treated pairs from the sample, and we run this regression. We have a time trend, we have a pause indicator, and an interaction between the time trend and the pause indicator. So what we are looking at is at a change in the time trends of control units in the aftermath of 2017, just to see if we detect that control units are experiencing any change following 2017. And in principle, we don't detect it, okay? This lambda is not significant. Again, maybe you don't have a statistical power to detect, or maybe the violation of this assumption is not large enough. So, I mean, maybe I cannot state certainly that this assumption is not violated, but what I can say is that at least it's not severely violated, okay? I can more or less rule out that this could be a problem. I did other checks. I ran a set of in-space and in-time placebo tests, so I assign fake treatments randomly to alternative countries, country pairs, to alternative periods. Then you run the estimations 500 times, and you see the distribution of these placebo estimates, and you compare your main estimates with this distribution of estimates. This is called randomization inference, and this suggests that my estimates have a causal interpretation, okay? When I randomly generate fictitious treatments, I don't get any effect that is higher than the one I report. More issues, more problems. Someone could say, okay, yeah, but in your control group, you have many country pairs, and maybe, I don't know, if you are considering the flows between Paraguay and Uruguay, and comparing that with the flows between France and Spain, maybe this is not fair. Okay, one way to check this is to run a logit regression on the probability of being a treated country based on observables, based on origin GDP, destination GDP, distance, having a common language and all that. We exclude those pairs with a probability below 0.1 and above 0.95, and we re-estimate the equation weighting observations by the inverse of the probability of treatment. This is called inverse probability weighting regression adjustment. Basically, the intuition is, okay, if this country pair in the control group is more similar to to a given country pair in your treatment group, then this control unit should be given a larger importance, okay, should be given a larger weight. And the estimates we get are consistent, okay, we get about the same estimates. Other issues, other comments we received was in previous discussions and some reports is to use alternative control groups, okay, maybe to use European origins only, European destinations only, or using only flows between European countries that do not belong to the European Economic Area, okay? And I list them, the countries that do not belong to this group. When we do these checks, we get very similar estimates and even larger in magnitude, okay? These first three are my main estimates in the baseline table I showed you before, and these are the regressions when I only use European, I use as controls European countries that are not treated, European countries that do not belong to the European Economic Area. And the magnitude is a little large. It is true that these European countries that do not belong to the European Economic Area are rather small. Okay, so maybe this is why these effects are big, because the comparison group is countries that are small. Another check is to exclude low-income countries. Okay, so the country with the minimum GDP per capita is Bulgaria in 2015, which is around $7,000. So we exclude origin and destination countries with GDP per capita below $1,000 to $2,000, $3,000, and the results are very similar. And another interesting exercise is to use domestic flows as a control group, okay? Because one could say, okay, but domestic flows should not be affected in principle. So maybe it's better to compare what happens to flows from treated countries to Spain as compared to flows within Spain that in principle are not affected by the policy. And to run this analysis, what we did is, okay, to do the comparison, we collapsed all tourism arrivals at the destination level. That is, I have for Spain domestic flows and the sum of arrivals from all treated countries. Okay, so I have, let's say, two groups for Spain, domestic and flows from treated countries. Then for France, the same, domestic and flows from treated countries, and so on and so forth. And I run this regression. And we get very, very similar results. Again, when considering all flows, the effect is slightly larger, 7%, but more or less in line. When I only consider arrivals, domestic and foreign arrivals, again, positive and a little larger. And when considering departures, around 8%. We also ran some heterogeneity analysis. We What we did is we classified countries into geographical blocks, Northern Europe, Southern Europe, Western Europe, and Eastern Central Europe. And we just consider an interaction terms, okay? The treatment indicator times the country to detect some heterogeneity. And here it seems that the policy stimulated arrivals mainly to Western and Southern countries from Western and Northern countries. Okay, in the other cases, the estimates in some cases contain the zero. So you see this marginally contains the zero, and this is also non-significant. So the effect seems to operate from, from Northern and Western countries to Western and Southern Europe, basically from the north to the south, more or less. We also consider interaction terms with origin GDP, destination GDP, distance, the dummy for having a common language, and the index of linguistic proximity. And what we get is that the policies greater or bigger in size, the effect for rich origins, and it's more relevant for comparatively poorer destinations. Okay, it stimulates trips from rich to poor in relative terms countries. It is more relevant for distant pairs, and it is less relevant for countries with linguistic similarity, which is coherent with this effect. Okay, it stimulates flows between countries that have different languages, different more dissimilar cultural backgrounds. Fine, this is the aggregate data evidence we have for the moment. Then we complement this analysis with microdata. And we take advantage that the Eurobarometer conducted two surveys, one in August 2017 and another one in May 2018. These surveys were conducted to a representative sample of European citizens, and they involve around 26,000 observations each. In the survey, people were asked about trips that they made to another European Union country in the last 20 months. Importantly, in the first round, which is August 2017, the question refers to before June 2017, that is, trips made before the policy was implemented. And in the second round, the question about trips refers to the period that goes between June 2017 and May 2018. Okay, so the question is exactly 1 year before in the first round, 1 year after in the second round. And the possible answers are 0, no trip, 1 trip, 2 or 3, and we cannot distinguish between them. This is a single category, 4 or 5 trips, or 6 or more trips. So we have an order indicator of travel frequency. Okay, this is an order indicator from 0 to 4. Apart from that, for those that declare having traveled within Europe in the first survey and the second survey, they are asked the frequency of internet use on the mobile phone while abroad, and it could be never, I don't use my mobile phone. It could be less often than at home, equally often than at home, or more often than at home. They were asked if they were aware about the policy change, yes or not, if they switch off their mobile phone and did not use it at all, if they switch off data roaming on their mobile phone, if they activated a special roaming plan in principle, this was what we need to do before this policy. If we wanted to use our mobile, we needed to pay our company a special plan, or if they use a SIM card bought at the destination country. Yes, no. So with this data, we run an auxiliary analysis. This is not the same individuals, okay? But assuming that the samples are representative, this is a repeated cross-section, and we can do somehow another difference in differences. We have country of residence fixed effects. We have an indicator for the second wave. We have an indicator at the individual level if he or she is aware of the policy change, and we have the interaction between if you in the second wave where the policy was implemented, you were aware of the policy change. And we have some other controls, okay? I have it here, gender, age, household size, education, and all this. And we run for trips an order probit, for these other actions, probit regressions, and for the frequency of internet use, I run multinomial logics. And well, here is the results. We have here all the coefficients, but I want to highlight the coefficient for this term. Okay, this term is, in the second wave, the differential effect among those that were aware of the policy change. And according to our regressions, these people traveled more. They were less likely to switch off their mobile. They were less likely to switch off the roaming service, the roaming data. They were less likely to buy additional roaming plans, and there's no effect on the SIM card, on the propensity to buy a SIM card, although the point estimate is negative. As for the frequency of mobile phone data use, the reference category, because this is a multinomial logit, is I don't use my mobile phone or data services while abroad. Okay, this is the reference category. So the coefficients should be interpreted with respect to that. And these coefficients are positive, and they increase in magnitude in this case. So it seems that in the second wave, among those that were aware of the policy change, there's an increase in the frequency of usage of mobile phone services in the post period. So, well, this is what we have. Let me say something, because we are not in a, I mean, I want to be very honest when I present a seminar, even though maybe some of you could be my referees, but I want to be honest. Here there's a little problem, which is the following. All these questions are only replied by those that travel. Okay, these questions you see here in the observations have around half observations, because they need to first jump the first step of traveling. So here, in these equations, in the regressions, there could be a problem of selection. Okay, these people are not randomly selected, and therefore, in the paper, we should see this survey data as let's say, as an additional evidence, maybe descriptive evidence, maybe I don't know. The key issue is the aggregate data, which is, let's say, more robust. Here, the survey data has some other problems. Maybe there are other omitted variables because these are different individuals, etc. But it seems that the survey data goes in line with the aggregate data. So please see this survey as just additional evidence, okay, not the core of the paper. So to end the presentation, okay, for the moment, and we are still, as I say, doing some additional issues. It seems that these roaming charts are relevant, okay, and apparently they increased intra-European flows by around 6%. It seems this effect is quite robust across different checks. The effects are stronger for fares that are long distance, one from the other, and also for linguistically different countries. This survey data suggests that individuals traveled after the policy with greater frequency. They were less likely to switch off their phones or roaming services. And therefore, this is the main message we have. Digital connectivity seems to be positive for international traveling because people finds it maybe easier to travel to other countries without having to worry about buying special roaming plans or having to pay additional money for their mobile. But anyway, as it happens with any differences analysis, you know, there may be, this is economics, okay? And we cannot replicate experiments as if we were in the lab. So there's always the risk of any other confounding issue operating here. But we try to isolate the policy as best as we can. And we believe the results make sense and are more or less consistent with the theory. And well, thank you very much for your attention, and I am now open for your comments and suggestions. Thank you.
Thanks a lot, David. I think we are going to have questions, so do not hesitate to raise hands if you have questions. Okay, Pedro, please.
Just to work as an icebreaker. So, David, congratulations. Yes. Thank you very much. I enjoyed your presentation a lot. I mean, it's very strong, I think, from my econometrical point of view, and I enjoy it a lot, so thank you. I have like 3 questions or short comments, but maybe it might be useful for you or not. The first one is, I was thinking if imagine that I am in a European country, I decide to travel to a different one. The roaming cost might be different depending on the country because this market is very oligopolistic. So maybe I am coming from a country in which is very expensive, and it might have some influence. I know that this is not something that you were looking at, but I think it might be relevant. If my country is very competitive with very low fees, even if I travel, shouldn't have a difference. If not, so this is a factor that might be relevant. The second comment is if you thought about the possibility of some kind of substitution effects. I mean, you mentioned that in a way, this is generating new demand, right? But now imagine that a country that is in Europe that is not part of this agreement. I don't know, Andorra, imagine, or another one, right? So it might happen that I am traveling more to countries in which I can use my mobile phone, but I am traveling less to other countries that are in the same area, but have not applied this policy. And I don't know if this is what you... And the last comment, it's very interesting because we were looking at if there is an increase in demand, but in a way, thanks to this, people is in a way also saving money. I don't know how much, because obviously it's not a very important component. So it might happen that it's not only increasing tourism flows, it might be increasing expenditure. And this is something that, again, I don't know if you look at. So this is in a way like additions, because from the point of view of all the tests you did, I have nothing to say, honestly.
Yeah, thank you. Thank you, Pedro, because really interesting comments. The first one about the differential fees across countries, this is a comment we received from a referee indeed, and we are working on it. My idea is to somehow collect data on pre-treatment fees, maybe 2016 fees, and try to see if the effect correlates or is stronger depending on the initial fees. because this could further show that the effect I am documenting operates through the policy, because just it is greater the effect in those countries that were for which roaming services were more expensive. And this is something we plan to do now, to link the treatment to the pre-treatment cost of traveling there in terms of these digital services. The second is something I mentioned in the presentation, the pseudo assumption. In any difference in differences, you need to rule out that the control group is affected by the intervention, and this is something, as you pointed, that may be happening. People stop going to one place and go to another. We did it, or we tried to do it by looking at differential behavior before and after 2017 in control units, but obviously it's difficult to separate these from general trends. And the way we approach this problem is to consider different control groups. One group is all other countries, another group is European countries not affected by the policy, another control group is domestic flows. Obviously, there could be contamination in all of them. This could be a possibility, but it's true that if you get a positive effect across different comparisons, maybe it's more convincing. And finally, this is a really good point, the potential translation of money. It is not, for me, it's not just that you save money and you use that money to spend in the destination, which obviously could be the case, but think about if you can navigate internet without restrictions, maybe you find out different attractions, different restaurants, different activities to do in the destination. This is an information, is access to information that maybe generates additional activities, not just the translation of the savings. It's just that I have more information. I take my phone and I just, where's the next or a nearby theater or museum or whatever, okay? And this is something to explore maybe in the future in a follow-up in case we are able to publish these papers.
Thank you, David. Thank you very much.
Thanks a lot. Anyone else?
Yeah, I raised my hand.
Yeah, please, Roberto.
Hello.
Go ahead.
Hi, David. Thanks
Hi,
for the very nice presentation. Oh, sorry, for those who don't know me, I'm Roberto Patuelli from the University of Bologna. I have two questions for you. One, by the way, I really like the idea of doing both, let's say, aggregate and micro level approach. I really appreciated that, although they're not exactly on the same thing, but at least they give two different perspectives, like a bigger picture. So my questions are this. One, I think I missed the first minutes because I was having a student exam, but I heard you excluded Croatia because, I guess, because they joined the. Did you say that you excluded Croatia?
No.
Because of compositional issues?
No. The sample period starts in 2014.
Yeah, sorry. You're right. That you cut off at 2014 because of Croatia, right?
Yeah, because if not, there's some compositional changes because if Croatia entered the European Economic Area.
Yes, but Croatia existed already. So, and also in particular as a tourism destination anyway, right? So if the problem is only that it entered the EU, you can obviously model the Croatia belonging or not to the EU, even, of course, that would be on the origin or destination level that is absorbed by the fixed effects. But you can also model, for example, bilaterally with dummy variables, whether the movement is, for any point in time, whether the movement is between EU countries or it's from an EU to a non-EU country or vice versa. You can model that. So if you have more data, why would you throw them away when you can model something, right? Unless this is a truly specific diff and diff problem, of which you are surely more expert than me. But the panel is the same. Belonging or not to the EU is just a characteristic that you can control even bilaterally if you want. Second question, you just were mentioning now, sorry, in answering one of the questions. Oh, sorry, I now forgot what was that about. Oh, yes. So you were saying that for the parallel trend assumption or the what was the name? Sudvar? No.
Mm-hmm.
You were hypothesizing that the control groups, the control group is not affected by the change of policy. Now, because we are in a spatial interaction gravity model framework. Now, the whole thing with the gravity model framework, in particular, when you go for a structured gravity model, as you are doing, should be that it is truly a general equilibrium model and not a partial equilibrium model. So the redistribution of the flows within the system are part of the game, are part of the theoretical existence, the theoretical foundation based on multinomial logic, or in the discrete choice, or maximum utility maximization of the gravity model. So if your diff and diff is based on the idea that a change in policy in one country does not affect tourism to other countries that don't have that policy, this is difficult. I think it's a difficult assumption to make, because it's obvious that if I don't know, say Croatia becomes more attractive, you are stealing tourism flows from another country that doesn't have the policy, and this is at the basis of the gravity model. You cannot imagine the gravity model without the general equilibrium redistribution aspect. Now, what you could do maybe is to hypothesize as a control group, not European countries, but countries that are so far away from Europe that they are much less likely to be a possible substitutes. Like Vanuatu or Hong Kong. They are so far away that they're definitely not going to be a substitute to Croatia or Spain. This could be a way to rule it out partially, not 100%, but 95%. Just food for reflection.
Yeah, thank you, Roberto, for your thoughts. As for the Croatia issue, yeah, I agree with you. This should be not a problem. It's just that we decided to use this 3-year window to at the very beginning, but some people, some referees mentioned, okay, why don't you go back a little and because the parallel trends is important here, if you have more years of data, you can better assess if indeed these treated and control units were behaving similar. Okay, so we plan to go back to 2011, another 3 years of data, and I can control, as you mentioned, the Croatia addition to Europe. And as for the other, this is a really relevant point. Indeed, I have been reading the gravity literature, also from the trade literature, not just the tourism, and they have these discussions if for causal inference there's any control group in terms of trade, in terms of tourism, that is not affected. For instance, these Trump tariffs, is there any control group or control country that is not indirectly affected by these policies? Well, it's a matter of discussion, okay? In any way, your recommendation is fine to use, okay, if this could be a problem, to use, I don't know, maybe flows between Asian countries, China and Hong Kong, China and Japan, maybe they could be comparable to European flows, and they should, in principle, not be affected by this issue, or less affected. And this is, again, my previous point, that I try to provide evidence with different control groups. Okay, so let's see what happens comparing with everybody. Then let's see what happens when comparing with domestic flows. Then let's see what happens when comparing to other European countries. And maybe, as you mentioned, let's see what happens when comparing to other developed countries that are located far away. And maybe if I continue getting the same estimates, then I can be more convincing.
Thanks. Any questions? To be honest, I have at least two. So maybe I can ask my own questions. First, this is not a question, but a comment and maybe a suggestion. I really appreciate the fact that you are proposing a small theoretical model. And I think that maybe you could add something, because the end of roaming fees in the European Union especially does not only affect the cost of information, but it also improves the tourist experience, as it has been said already by Pedro, I think. My point is that because you have in general, a huge available amount of roaming data, you are using it as if you were at home, meaning that you can really benefit from all the amenities proposed by the destination, including something that was impossible before, that is sharing your experience with people that are in your origin country. I mean, now you can have a video conference call live from a place that you visit. It was impossible 15 years ago. And it also has a value in terms of utility of the experience. So maybe you could mention it in the paper, not only through the cost component. And then I have a question that might be silly, but I'm assuming not, so I ask it. You decided to skip the GDP and all these mass variables that are used typically in this kind of models. And my understanding of those variables, such as GDP, population, and so on and so forth, is that they are supposed to be a way to account for characteristics of the country in terms of, I would say, how it impacts the ability of the country to trade or to have tourism flows with other countries. And my point is that I'm a bit puzzled by the huge effect that you find, because I think that 6 percentage point is a lot. And I was wondering if in this context, it could not be useful either to introduce in a robustness check this kind of variables, just to rule out the possibility that it has an effect on the magnitude of your findings. And my second point is that maybe another way to do something similar is that instead of using only per fixed effect, you could also include country fixed effect. my point being that, for example, Spain has huge tourism flows with a lot of countries, and you cannot only account for the bilateral flows using the per fixed effect. This is my understanding, but maybe, as I said, I'm no expert on this kind of modeling, so maybe it's silly, but maybe you will answer.
Thank you, Sawa. As for the first point, really relevant. I did not consider that, but I think it's really important because, as you mentioned, maybe the cost part is not so relevant as the other part, as the possibilities in terms of utility, in terms of the translation of the destination amenities into consumer utility that these services give you. Okay, so maybe in the model there's, I don't know how, but these data services affect the betas that go with the axis, with the characteristics. Okay, so I can think about developing a model that incorporates that. As for the other, okay, this is another issue. If you think about a standard panel data set, okay, imagine that I tell you, okay, countries have different size, square meters, which is time invariant. So rather than estimating a fixed effects model, why don't you control for size? For instance, no? But if you replace the country fixed effects by size, you may have omitted variable bias, okay? Because size is one characteristic, there might be others. In the gravity equation, what I do is to use origin year and destination year fixed effects, which implies that I have an effect for Spain 2014, Spain 2015, Spain 2016, and because of how I have an effect for each of them, GDP cannot be introduced because it's overlapping with these fixed effects. I could do your check just to see what happens, which is a standard fixed effects plus the GDP and see if the effects more or less, maybe it's not the same, but more or less remain the same. But in this differences literature, there's a lot of discussion now, and the people that are using causal inference in the gravity equation are saying, look, it is much better to control for origin year and destination year fixed effects rather than controlling for GDP, because you think about GDP, but maybe it's natural disasters, maybe it's terrorism, maybe it's many other dimensions that you could think of, or maybe you have the data, or maybe you don't. But it is true that I can do the check, even if it's not as clean, I can do the check and see if the results are similar. Okay, so this is how I can proceed.
Thanks a lot, David. Thanks. If there is no other question, and I think this is the case, I think it's time to say goodbye to all of you. I would like to thank you all for being with us, and also would like to thank Uriol and Veronica first for their involvement in the organization of this event, and then for inviting me to moderate this session. And the next session will be announced shortly, so we keep in touch. See you next time, and I hope you enjoyed, as I did, this presentation.
Thank
you, everyone.
Thank you.
Thank you very much.